I want to say a little bit more about the tangent line. We've been thinking of getting the tangent line as sort of a three-step procedure, and that's usually the right way to do it, but sometimes we need to put that into a one-step formula. It's a little dangerous to do that. So what we've been doing is we've been taking f of x and calculating f prime of x. That's as a function, and that has x's in it. Then a really crucial step that people often forget, and they often forget more in the version I'm going to tell you in a minute, plug in x equals a, the specific number. Since a is from the beginning of the alphabet, the idea is that that's more likely to be a specific number, a constant, okay? To get the slope, call it m, and then do point slope, y minus y1 equals m x minus x1. Okay, you can combine those into one fell swoop, and let's see what that does. Okay, and then we'll do a quick example. So we've got. Let's go back to the third step, point slope. I need to have the y value. Well, that's the y value for the point of tangency. That's going to be f of a. I need the x value. Well, that's a itself. And then the m is f prime of x, but evaluated at a. Okay. So what we're going to get is a master formula. Y minus f of a, that's what that turns into, equals f prime of a times x minus a. And so that's a good way to write it. Often, we want everything solved for y, and so it's going to be f of a, the value, plus f prime of a, x minus a. And it's really, really important that this and this and this are numbers, just plain numbers. There should be no x's in them at all. If there's any x's in them at all, you're going to get something that's more complicated than the formula for a straight line. Okay? We should just end up with something like y equals 2x minus 3 or something like that. Only one x on the right-hand side. If you just remember, only one x on the right-hand side, it's a line that's going to save you a lot of trouble. So let's do a quick example. And then in another video, I'm going to show you how this master one-step formula can do some more complicated problems. So let's say we just have some function. I'll do a fake graph here. But let's say a is equal to 2. And let's say this is a pretty fake graph of, let's say, y equals x cubed minus x squared plus 3. It's not really what it looks like, but close enough. Okay. So we take, that's our f of x. So we take f prime of x, and that's going to be 3x squared minus 2x. And then immediately we plug in the a value. That's our a value, the point at which we want to calculate the tangent line. Okay, and so that's going to be 3 times 4 is 12, minus 2 times 2 is 4, equals 8. Okay. So that's exactly how we would have started the problem in the first place. It's just that the next step is just, okay, we know what the answer is. We can just slot everything in. Oh, except wait, we don't have f of a. Ooh. F of a, or in other words, f of 2, we still need that. That's going to be 8 minus 4 plus 3 is 7. Okay. So our tangent line is going to be y equals 7, that's the f of a, plus the slope 8 times x minus 2. And then if we want to simplify, we can. 8x, and then plus 7 minus 16 is minus 9. And we got it in mx plus b form, although this is often just as good. Okay. So that's an example of ever so slightly tightening that up. That wouldn't be worth it, really, probably, unless we had a better use for it, but we'll show a more complicated problem in another video.